Alright, problem A, stating the domain of this function. I made a mistake in the original video when your classmates caught it. Thank you, undisclosed classmate. So what are we looking for? We're looking for x values that make this function undefined. What x values do that? Well, we're looking for x values in the denominator, because if you have a 0 in the denominator, the entire fraction is undefined. You cannot divide by 0. So what x values make the denominator equal to 0? Well, in this one, we get x equals 1. So x cannot equal 1, because if x is 1, we get 1 minus 1 is 0. And that's a problem. Well, what about this factor? This factor says that x cannot equal -7, because if you plug in -7 for x, you get -7 plus 7 is 0. What about this last one? Well, that says that x cannot equal +2, because then you get 2 minus 2 is 0. So domain is just going to be x in the set of real numbers such that x is not equal to 1, and x is not equal to -7, and x is not equal to +2. And would it have been better if I had put those in numerical order? Probably, but I'm really, really tired at this point, and I need to go to bed. So maybe I'll try and appease you by doing a little switcheroo right there, and now you best be happy, because now it's correct. If you wanted to do interval notation for some strange reason, you would have to say that x is in the interval starting at -infinity and continuing up until we get to this first awkward bit at -7. And we do not want to include it, so we put a parenthesis, but then we union it with another interval starting at that same awkward bit but not including it, going up to the next awkward bit at 1, not including it, and then union that with another interval starting at that awkward bit but not including it, and going up to the last awkward bit but not including it, and union that with an awkward bit, not including it, and going on forever. But hopefully you see that in this instance, set builder is a lot less annoying.